The operation of division can be thought about as fair share. There's a couple other interpretations for division, but the fair sharing idea is perhaps the most basic. So in this division problem, 15 divided by 5 is equal to 3. Again, we have special names for each number in the problem. This 15 is called the dividend. The 5 is called the divisor. And this 3 over here is called the quotient. Now sometimes we say that it does not divide evenly, and then we'll get something called a remainder, and we'll look at that in just a moment. So relating to this idea about fair share, I can think about this as if I have 15 items, and I want to split them between 5 buckets or containers, however you want to think about it. So I'm just going to do 5 containers here. 1, 2, 3, 4, 5. So if I want to split these 15 items up equally, so maybe I'll put 1 in each bucket so far. So 1, 2, 3, 4, 5. So out of these 15 items, I've already placed 5. I'll have 10 items left to place, so let me place some more. So I'll place 1, 2, 3, 4, 5. So out of my 15 items, I've placed 5 more, so now I've placed 10 total. I have 5 items left to place, so I'll place 1, 2, 3, 4, 5. And now I've run out of items to put in the buckets. So the answer is how much ended up in each bucket. And we can see that there's 3 items in each bucket. So that's the idea about fair share. 15 items shared equally between 5 buckets means each bucket will get 3 items. And just so you're familiar, there's a couple different ways I can represent this division problem, just like there was a couple different ways I could represent multiplication problems. So this division problem can also be represented as 15 and then using a fraction bar. And I can still verbally say it as 15 divided by 5 is equal to 3, but sometimes we'll say it as 15 over 5 is equal to 3. Or another way I could write this is with a symbol that is often used for long division, which is 15, and then we'll put this curved line next to it with a bar on top of it. And then we will put the 5, our divisor, over here to the left, and then the quotient we write above the line. So that is the structure we usually do for long division, which is actually how we figure out when we're doing a division problem by hand, how we figure out what that quotient should be. We set it up in long division. So let's take a look at that. In this fraction structure, by the way, we will do a deeper dive into fractions a little bit later. So if I want to divide 84 divided by 6, so in other words, if I have 84 items and I want to split them equally between 6 buckets or 6 containers, how much would each container have? So we can set this up in our long division. So I'll put 84, that dividend, underneath this long division symbol, and then the 6 will go over here to the left. So how we do this long division is first we're going to ask ourselves, how many times does 6 go into 8? So notice I'm going to just kind of ignore that 4 for a moment. I'm just going to look at that 8. So how many times can 6 go into 8? Well, it can only go in 1 time. 1 times 6 is 6, so I'm going to put that multiplication result underneath the 8, and then I subtract going down. 8 minus 6 is 2. That's the remainder just from that step. At any point in time, this remainder needs to be smaller than this number out here, your divisor. If this number down here had been 6 or bigger, that means above the line we could have gone in another time. I have another number right here, so I'm going to bring it down. We're going to bring that down below the line. And now the number I'm looking at is 24. And I would ask myself, how many times does 6 go into 24? No, it goes in 4 times. 4 times 6 is 24. We subtract going down, and we get 0. Since I don't have any more numbers to bring down, I'm done with the division process. my remainder is 0. We usually would then say that this divided evenly, and then I would say that 84 divided by 6 is equal to 14. Division always has a related multiplication problem, so if you're not sure if you've done this correctly, you can check it. So what must be true then is if I take 14 and I multiply it by 6, I need to get back to 84. Otherwise I've done something wrong. So let's go ahead and just do that multiplication real quick. 6 times 4 is 24. We'll put down the 4, carry the 2. 6 times 1 is 6, plus 2 is 8. I wanted 84. I got 84, so it checked out. Alright, so this number was special, or this problem was special because my remainder was 0 for the overall problem, and so then the 14 was just my answer, which is called our quotient. Alright, let's try a number just a little bit longer. We'll divide 939 divided by 4. So we'll set it up the same way. The 4 will go on the outside of the division bar, the 939 will go underneath. I'm going to first look at, does 4 go into 9? And it does. It will go in 2 times. 4 times 2 is 8, so I'll put that down and then subtract going down. Notice I'm ignoring these other 2 numbers, I'm just looking at the 9 at this point. 9 minus 8 is 1. So that's the remainder in that step. It's looking good because this number is smaller than that, so I went in enough times. Now I'm going to bring down the next number. Just the next number, not the next 2 numbers. So then I'm going to ask myself, how many times does 4 go into 13? Well, it goes in 3 times. We'll put that above the line. 3 times 4 is 12. Put that right here, and we'll subtract going down. 13 minus 12 is 1. And now I'm going to bring down the next number. Alright, so this will be the last time I go through because I got no more numbers to bring down. So here we go. How many times does 4 go into 19? Well, it goes in 4 times. 4 times 4 is 16. We'll subtract that going down. 19 minus 16 is 3. So this one's a little bit different than the one we just looked at because this one I have a remainder. The remainder is 3. So we say that this does not divide evenly. I would have this kind of like leftover piece. So we just found that 939 divided by 4 is equal to 234 R3. So 234 worth a remainder of 3. There is another way that we can write this using fractions and mixed numbers that will be explored later. So to kind of visualize what's going on with that idea about fair sharing, let's say that I have 939 items and I want to split that between 4 buckets. So 1, 2, 3, 4 buckets. What this answer is telling us that each bucket, if I want to do fair sharing, each bucket would get 234 items inside of it, but I would have 3 items left over. And I can't really put those 3 items in the bucket because then I wouldn't be able to fair share. Every bucket wouldn't be able to get 1 item. So that's just kind of like the leftover piece. Now again, we can check this. So to check division, we check it using multiplication, but because we have the remainder, we'll have this little leftover piece we have to deal with. So to check this, I would first say, what is 234 times 4? All right, so let's do that, just that multiplication. 4 times 4 is 16. We'll put down the 6, carry the 1. 4 times 3 is 12, plus 1 is 13. We'll put down the 3, carry the 1. 4 times 2 is 8, plus 1 is 9. So that's 936. Right? So by the way, that is exactly how many items were fair shared between the buckets. If you do 234, 234, 234, 234, and you add those together, that's the same thing as saying 234 times 4. Remember, multiplication indicates repeated addition. So we have 936 items split between the buckets. But for the remainder, how we account for that in this problem is we're going to add the remainder. So 936 plus my remainder of 3 gets me 939. And yep, that is exactly what we started with our divisor, so this checks out. Okay, so this is an example of a problem. The first one, it divided evenly, no remainder. The second one, it did not divide evenly. We did have a remainder we have to deal with. Both of those divisions involve dividing by a single digit number, which is considerably easier than if we want to set up a division problem where the number on the outside is longer, so maybe like 2 digits. So let's take a look at how we would do something like that. So what if I wanted to divide 534 divided by 24? So we're going to set it up the same way. So 24 is going to go on the outside, and the 534 will go underneath. So then I'm going to ask myself, how many times does 24 go into 5? Well, it doesn't. 5 is too small. So then I'm going to say, how many times does 24 go into 53? So here's where estimation skills come in handy. To be able to maybe take this number on the outside, your divisor, and maybe make it something easier to work with. So maybe we want to think about 24 as being close to maybe 20 if you're comfortable working with that, or we can think about 25 because working with quarters in our money system, that might be easier for you to work with. So I'm thinking about this being kind of 25. 25 times 2 is 50, and 50 is really close to 53. So I'm thinking that I'm going to see if 24 can go into 53 2 times. So I'm going to put the 2 up there. So this was just an estimate to kind of see how many times I should go in. Now I'm actually going to need to do the multiplication to figure out what number should go underneath here. So 24 times 2. All right, 2 times 4 is 8. 2 times 2 is 4. So that's 48. I'll subtract that off. And then 53 minus 48 is 5. So that's looking good. This number right here, which is the remainder just at that step, is smaller than my divisor. So I wouldn't be able to go in any more times, and so everything's looking good so far. So now I'm going to bring down the next number. So this is really close to kind of what I started with, so I can use the same estimate. How many times do I think 24 will go into 54? Well, I think it's going to go in 2 times. Because 2 times 24 is 48, and that seems really close to 54. So again, I'm going to subtract going down, and then 54 take away 48 would leave me with 6. There's no more numbers to bring down, so I would be done with the division process. So what we just found was 534 divided by 24 is equal to 22, remainder 6. So when you're doing the long division, if you have to do it by hand and this number out here has more than 1 digit, it's helpful to do some quick estimates to kind of see how many times we think we should go in, and then use those estimates kind of to fine-tune. You're actually doing the multiplication to figure out what we need to subtract, and then adjusting as needed.